Okay, pre-calc kids, this is all about trig. This is our first day of trig, remembering trig, and I cut and pasted this from your textbook, but it doesn't look like you can read it very well. But you do need to know all 6 of the functions, and you need to know these 3 you probably know pretty well, sine, cosine, and tangent. That we learned with our friend SOHCAHTOA, I'm assuming, where we had sine is the opposite over the hypotenuse, cosine was the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. Now, I don't know how much time you spent with the cosecant, the secant, and the cotangent. Those are the reciprocal functions. Cosecant is the reciprocal of sine. So cosecant, CSC, cosecant of theta. Theta is the symbol we use a lot for angles. It's a Greek letter. You probably heard about it because there's a new storm named Theta, which makes it's very sad. So cosecant theta is the reciprocal of sine, so it's 1 over sine. Or because sine is opposite over hypotenuse, it's the hypotenuse over the opposite. And that's what that says up there, and you can look through your book on that. Secant is the reciprocal of cosine, and the only way I remember that is that it's backwards, which is a silly way to remember it, but that's the way I remember it. And then cotangent is the reciprocal of tangent, and it's the if tangent is opposite over adjacent, this is adjacent over opposite. So there's no cute little SOHCAHTOA for cosecant, secant, and cotangent. These are just things you have to know. So when I look at this triangle that I have in front of me, these sides are 7, 25, and 24. That's a right triangle. If you use the Pythagorean theorem, 7 squared plus 24 squared is equal to 25 squared. So I know it's a right triangle. If this is my angle theta, okay, then I want to be able to find all of these functions. So what's the sine of theta? Well, if that's theta, then the opposite is this side over here, which is 24, and the hypotenuse is always the same, 25, opposite the 90 degree. Cosine is the adjacent over the hypotenuse, and adjacent leg is the one that's right here. The adjacent side is the one right next to the theta. That's why we call it adjacent. So it's 7 over 25. Tangent of theta is opposite, which is 24, over adjacent, which is 7. And then when I start doing the other ones, so the cosecant, which is the reciprocal of sine, all I have to do is flip over sine. Sine is 24 over 25, so cosecant is 25 over 24. Secant is the reciprocal of cosine. Cosine is 7 over 25, so this is 25 over 7. And then cotangent is the reciprocal of tangent, so that's going to be 7 over 24. So if you can do sine, cosine, and tangent, you can do secant, cosecant, and cotangent. All right, now you do need to remember some of these special values. And so the 45 and the angles that I'm talking about special are 30, 45, and 60. Those are the ones that you're supposed to memorize, your sine, cosine, and tangent. It's really not that hard to memorize them. I'm going to try to show you, first of all, 45, because it's easiest. So I have a triangle here that's isosceles, because 2 sides are the same, which means 2 angles are the same, right? So what I'm looking at here is when I do the sine and cosine of 45, they're going to be equal. The sine of 45 is equal to the cosine of 45 because the opposite and the adjacent sides are both the same. Now the only thing I need to do is figure out what is that hypotenuse. Well, that's where the Pythagorean theorem comes in. A squared plus b squared equals c squared. So 1 squared plus 1 squared equals c squared. So c is the square root of 2. So when I do the sine of 45 and I do the opposite over the hypotenuse, right? So opposite over hypotenuse, that gives me 1 over the square root of 2. Well, we're not supposed to write square root of 2 in the denominator, so I'm supposed to multiply top and bottom by the square root of 2. So the sine of 45 is the square root of 2 over 2. And so is the cosine. So those are easy to remember. Cosine 45. So these things need to be into your brain. Okay, so that's 45, 45, 90. And if you don't remember exactly, you can always just figure it out like I just did, which is a lot of time consuming, but not that hard. Okay, so as I ramble here, now let's do the 30 and the 60. And those are easy enough because they are in the same triangle. And if you can remember the triangle, you can remember the functions. So we take an equilateral triangle. All the sides are 1. And what we do is we draw the altitude. And in an isosceles triangle, the altitude splits the base into 2 congruent parts. So if the whole thing is 1, that means each part is a half. So that means if I take this triangle that's on this left side, this one, and I bring it over here by itself, I know that this side over here is 1/2. This is a right angle. Now all I have to do is figure out what is that other side over there. Oh, by the way, going back to this is going to be 60 degrees, right? And the altitude not only cuts the base in half, but it also cuts the angle in half. So that's going to be 30. So this is my 30, 60, 90 triangle. And they're always in the same proportions. So if I want to find this side over here, I'm going to use my Pythagorean theorem again, but this time it's a leg that I don't know, x squared plus 1/2 squared. So 1/2 squared is 1/4. So 1 minus 1/4 is 3/4 equals x squared. So take the square root of both sides. It's the square root of 3 over 2. So square root of 3 over 2, that's how that's easy enough to do. So now it's easy because the hypotenuse is 1. So if I look at 60, if I look at the sine of 60, 60 is opposite over hypotenuse. Well, opposite for 60 is going to be the square root of 3 over 2 over 1, which is just the square root of 3 over 2. The cosine of 60 is adjacent over hypotenuse, which is 1/2 over 1, or just 1/2. And when I do 30 up here at the top, okay, now my opposite side is 1/2. So I know that the sine of 30 is 1/2 over 1, or just 1/2. And the cosine of 30 is square root of 3 over 2. So notice they share things, and the one that I remember, for whatever reason, I have no idea why, but is this sine of 30. I remember the sine of 30 is 1/2, and if I can remember that, then I can figure out all the other ones. So you need to somehow figure out a way to memorize those. You can type into your calculator sine of 30 is 1/2, but when you type into your calculator the cosine of 30, it's going to give you a decimal. You kind of have to know that it's radical 3 over 2. You have to know the exact values. Okay, so moving on. Now let's apply those things, and we did this, you did this last year, I'm certain of it. Here's a 45-degree angle. Well, that means this angle over here is 45, right? And that means that A has to equal B, right? Great. So now I can find either A or B, okay? So, and I can use sine or cosine. I can say the sine of 45 is equal to, the sine of 45 is A over 10. So this is 10 times the sine of 45 is square root of 2 over 2. Sometimes I have to use exact values. I can't use decimal approximations. So that makes 5 square roots of 2 is equal to A. If it doesn't say, I can use my calculator, but lots of times I'm supposed to use exact values. That's why we have those angles. If I have weird angles like this one, then I don't have to worry about it. So what is side T? What is side S? Notice I'm missing a bunch of things, right? I have an angle and I have a side opposite. This is the opposite. So let's say I want to find the hypotenuse. So opposite hypotenuse would be sine. So the sine of 26.7 is opposite 0.17 over the hypotenuse. Oops, that's got the letter S on the diagram. I hate the letter S, but it's the letter S. Okay, so now when I solve for S, I want to make sure that S is equal to 0.17 divided by the sine of 26.7, whatever that is. I have to make sure my calculator is in degree mode. Most of your calculators will be in radian mode. So 0.17 divided by the sine of 26.7 is S is equal to 0.38. And now I want to find this side. This is my adjacent side. And if I can avoid using what I just calculated, that's the best. So I'm going to go ahead and use tangent of 26.7 is equal to opposite, which is 0.17, over adjacent, which is t. So if I solve for t, t is equal to 0.17 divided by the tangent of 26.7. So 0.17 divided by the tangent of 26.7 on my calculator, and t is equal to 0.34. Now, always make sure that your hypotenuse is the longest, because that always has to be the case. So 0.38 is indeed longer than 0.34 or 0.17. Okay? Here's another one. A, B, and C are given. I think I'm going to save this for another video and finish out in the next video. All right, this is day 1.